What's up, guys? Thank you for clicking on my video. Today I'm going to be doing a review on Calculus 2. Most of Chapter 2 we're going to be covering areas between curves, determining volumes by slicing, volumes of revolution, cylindrical shells, arc length of a curve and surface area, physical, and finally physical applications. You guys might have gotten not different questions, but all of the questions are pretty much the same, just that some of them have like different values, like different numbers. But the ones that I'm gonna do, you guys are gonna be able to do them with your own questions if you didn't already get the same ones. So let's get straight into it. So problem number 1 tells us to sketch the graph of y equals 3x and y equals 4x squared and find the area bounded by these curves. So I already went ahead and sketched the graphs here. If you have a calculator, you can skip the following steps, but the first thing that I'm gonna do is I'm gonna find the bounds of these. But if you have a calculator, you could just like analyze the graph and you could see the points. Anyways, to find the bounds, we're gonna set these two equations equal to each other. That's the first thing that we're gonna do. We want to find the bounds of, and we're gonna find the area of this region right here, this red that I scribbled. So to find the bounds, we're gonna set these guys equal to each other. So we have 3x equal to 4x squared. The first thing that I'm gonna do is I'm gonna divide by x right here. So then we are left with 3 equals 4x, and now we want to get x by itself. So divide by 4. So x is going to be equal to 0.75. I like to write my things in decimals, not fractions, because fractions can get messy sometimes. And that's the upper bound. The lower bound right here is going to be 0 because going back to this one right here, if we plug in 0 for both of these, they're both going to be, for the x, they're both going to be 0, so that'll make it true. So we have x equals 0.75 and x equals 0. All right, so now that we have our bounds, I'm just going to write the integral already. So we have from 0 to 0.75. And then to find the area between curves, we do the top function minus the bottom function. So in this case, the top function is this black one right here, which is y equals 3x. So it's going to be 3x minus the bottom function, which is the red one, which is 4x squared. And actually, like, there are some parts where the top function is the red one and not the black one, but in this case we're just going from 0 to 0.75, so we just care about from here and here, well, the part that I shaded. So yeah, anyways, this is with respect to x. Now that's pretty much it for this problem. Now we're just gonna integrate. This is a simple reverse power rule, so that's gonna be 3x squared over 2, not plus, minus 4x cubed over 3. And we are evaluating from 0 to 0.75. Now, if we were to plug 0 in these, in this, that would just come out as 0. So we could just skip that and go straight to 0.75. So we have 3 times 0.75 squared over 2 minus 4 times 0.75 cubed over 2. And for this problem, your answer should be 0.28125. And since this is area, it's going to be units squared. Make sure that on the test you do write units squared, because you might get points taken off if you do not write units squared for area. And that is your answer right there for the first problem. Okay, so the next problem says to sketch the graph of y equals x squared plus 1 and y equals 4x squared, and to find the area bounded by these curves. I already drew the bounds, but anyways, let's just go ahead and find them. If you have a calculator, it's going to be a lot easier, but I'm going to do it algebraically. So this is it's going to be the same exact steps as the last one. So we're going to set these two functions equal to each other. So we have x squared plus 1 equals 4x squared. What I'm going to do here to get the x's by themselves is I'm going to subtract this side by this whole thing. So I'm going to do minus x squared plus 1. Or, actually, I can just do minus x squared. Minus x squared. I'll get 1 equals 3x squared. Divide this by 3. Now we have 1 over 3 equals x squared. Now to get rid of that squared, we take the square root. So then x equals square root of 1 over 3 and x equals negative square root of 1 over 3. So those are going to be our bounds. So now I'm going to write the integral. So we have the integral from negative square root of 1 over 3 and square root of 1 over 3. And since I already have it drawn out here, it's going to be very easy to find the top function and the bottom function. The top one in this case, or the top one within the bounds that we're looking at here, is going to be the black one, which is x squared plus 1. So it's going to be top function minus the bottom function, which is the red one, which is 4x squared with respect to x. Now I'm going to combine like terms here. So we have the integral from negative square root of 1 over 3 to the square root of 1 over 3. That looks like a y, but it's a 1 over 3. And we'll have 1 minus 3x squared with respect to x. Okay, and then here, now we can integrate. It's going to be a simple reverse power rule. So we have x minus 3x cubed all over 3, evaluating from negative square root of 1 over 3 to the square root of 1 over 3. I'm going to go ahead and erase this just so that I don't have to write down here. And if you'll notice, these guys cancel out. So now we're evaluating x minus x cubed from these bounds. So I'm just going to go ahead and write that already. So we have square root of 1 over 3 minus this one, square root of 1 over 3 cubed minus negative square root of 1 over 3 minus negative square root of 1 over 3 cubed. And you guys can plug that into the calculator on the test. I'm not going to show it here on the video, but your answer is going to be So our next problem says to find the area of the region bounded by the graphs of y equals cos x squared and y equals sine x squared. And I was supposed to write this in red, but I'll just circle it. This is our red function, and this one is our black function. And luckily for this one, they already gave us the bounds. And since I already have it drawn out here, we already know which function is on the top and which one is on the bottom. So let's just go ahead and write that out already. So we have the integral from negative pi over 4 to pi over 4. And we have the top function, which is cos 2x, minus the bottom function, which is sine 2x. I mean, not sine 2x, but sine x squared and cos x squared with respect to x. Now, here, we have to recognize this as a trig identity. Otherwise, to be honest, I probably could figure out how to solve this another way, but it's so much easier just with the trig identity. So this is actually this cos x squared minus sine x squared is actually just, or can be rewritten as cos of 2x, if I am not mistaken, and I'm not. Okay, so now we are going to integrate this much simpler function. So we have from negative pi over 4 to pi over 4, and we have cos of 2x with respect to x. Here we're just going to use a simple u substitution. So I'm going to let u equal 2x. The derivative of u is going to be equal to 2 dx, and I like to get dx by itself. So if we divide by 2 here, now we have dx equals du over 2, and now we can rewrite this thing in terms of u. So we'll have the integral from pi over 4 to negative pi over 4 cos of u du over 2. Um, Here it is. I'm gonna erase all of this and I'm gonna rewrite this at the top because I'm running out of space. Okay, so from here, we can pull out that 1/2, and we're just gonna integrate cos of u. There's this thing that my high school calculus teacher taught me, which was this I guess is like an acronym. So for integrals, if the answer starts with a c, answer is negative. The integral of cosine is sine. That's pretty basic to remember. It's just the negative and the positive that people have trouble remembering. So we have this if the integral, I mean, for integrals, if the answer starts with the c, answer is negative. This one does not start, this integral starts with the c, but the answer starts with an s, so this is not going to be negative. So we have, I'm going to skip a couple of steps, but hopefully you guys can see what I do right here. So we have sine u over 2 and evaluating from negative pi over 4 and pi over 4. And actually, I'm going to keep this 2 out because I feel like I'm just going to keep it out right now. But we have that 2 right here. So now we're just going to evaluate. And I erased it, but luckily I remembered that u is equal to 2x. So let's replace u again right here. So we're evaluating the sine of 2x from negative pi over 4 to pi over 4. Now, you can plug this into the calculator if you want. If you want to do it like by hand, I guess you would draw the unit circle right here. So we have our unit circle right here, and now we are gonna evaluate our things. I mean, our bounds. So we have the sine of 2x, 2x, and then x is pi over 4. So that's actually 2 pi over 4 minus the sine of negative 2 pi over 4, which can actually be rewritten as sine of pi over 2 minus the sine of negative pi over 2. So pi over 2 is going to be right here. So this sine of pi over 2 is going to be 1 minus the sine of negative pi over 2, which is going to be this way, or going, I'm not even going to say because I'm going to make a mistake, but we're going this way for the negatives. So that's going to be right here, which is going to be negative 1. And 2 negatives makes a positive. So we have 2, but remember we pulled out that 1/2. I probably should have written it right here. 1/2, 1/2. So 2 times 1/2, or basically 2 divided by 2, which will give you a final answer of 1. And since we are finding the region, again, I forgot to draw it over here, but it's this region right here. This region right here is equal to 1 unit squared. The next problem says, suppose that R is a finite region bounded by y equals x and y equals x plus 5 from x equals 0 to x equals 2. Find the volume of R when rotating around the x-axis. So now we're finding volume, and luckily we already have the bound. So we have from x equals 0, so x equals 0 right there, to x equals 2, which I'll just call it like right there. So, and then we're going to rotate around the x-axis, which is this one right here, which is very nice because we don't have to do any weird extra work. So now we are just going to, oh, since we're rotating these two functions around the x-axis, once we rotate them, it's going to be like a disc, basically. It's going to look like a disc. However, we are going to have this empty space right here. So what I'm going to do is I'm going to use the washer method, because we have this radius on the top and then this radius on the bottom, and we're going to subtract this radius on the bottom. So yeah, I'm just going to start. So we have the integral from the bounds, which are 0 to 2. And when we're doing, when we're finding the volume of a revolution, of a solid revolution by the washer method, we do pi and then the big radius minus the smaller radius with respect to whatever we're doing. In this case, it's going to be x. I mean, not whatever we're doing, but in respect to the variable that we are integrating. Anyways, we have these functions, so let's go ahead and plug them in. So we have from 0 to 2, and I'm going to go ahead and plug that, take that pi out for right now. We have r squared, big R, which is the red one right here, the big radius, which is x plus 5. X plus 5 squared minus the little r, which is just x squared. All of that with respect to x. I'm going to use the FOIL method to expand this. So we have x plus 5 multiplied by x plus 5. The FOIL method is first, outer, inner, last. First is going to be these x's. So we have, I'm just writing right here, x squared. The outer is going to be these two guys, so that's plus 5x. The inner is going to be these two guys, so that's going to be another plus 5x. And then the last is going to be this guy and this guy, which is plus 25. So we have x squared plus 10x plus 25. Now I'm going to rewrite this over here now that we have it expanded. So now I have pi integral from 0 to 2 x squared plus 10x plus 25 minus this x squared with respect to x. Notice how this x squared is going to cancel out with this one. So then we are really just left with pi integral from 0 to 2 of 10x plus 25 with respect to x. I'm going to erase this work. So now we can integrate. This is going to be a simple reverse power rule. So we have 10x squared over 2 plus 25x evaluated from 0 to 2, and then we're going to multiply it at the end by pi. So first of all, this will simplify to 5x squared. So we have 5x squared not over anything plus 25x. And oh, I forgot a step right here, but since we have a 0 on the bottom, if we plug in 0 anywhere here, it's just going to make the whole thing 0. So we could just ignore the 0 and we'll just do the 2. So 2 right there and 2 right there. 2 squared is 4 times 5 is 20 plus 25 times 2 is 50. 20 plus 50 is 70. Bring down that pi. Your answer is, let me make sure I'm doing this correctly. Yeah, 70 pi. 70 pi, and since we are finding the volume, this is now going to be units cubed. The next problem, problem number 5, says find the volume of the solid obtained by the given curves about the specific axis. So we have the curve y equals x to the 8th, which is this red one. And then we have the line y equals 1, which is this black one right here. And we're going to rotate it about the line y equals 4, so this top one right here. So to do this one, I'm going to use the washer method, because we are, once we rotate this around this line, we are going to have this outer radius and this inner radius. So I'm going to use the washer method. However, before we set up our functions, we do have to do one thing. Since we're not rotating about the x-axis, but we're rotating about the line y equals 4. So we have to take into account how far each of these functions are from the line that we're rotating around. So the washer method says from A to B, pi times the big R squared minus the little r squared with respect to the variable that we're integrating with, which in this case is going to be dx. It's going to be x. And now, first of all, before we even do anything, we have to find the bounds. So to find the bounds, we set the two functions equal to each other. So we have x to the 8th equals 1. Take the 8th root of both sides. We just have x equals 1 and x equals -1. So those are going to be our bounds, -1 and 1. So let me go ahead and pull that pi out. So we have -1 and 1. And then we have the big radius squared. But again, like I said, we have to take into account the fact that it's a certain amount away from the line that we're rotating around. So in this case, how we're going to write that is we're going to do, since this line is at 4, we're going to do 4 and then minus the function. So 4 minus x to the 8th squared minus this one, the black one, which is the same thing. So it's going to be 4 minus 1 squared. Now, I'm not like, I understand why I did this, but I don't understand it enough to fully explain it to you guys. But like, I'm hoping you guys understand that I'm doing this because this function is already like a certain distance away from the line that I'm revolving against around. If we were rotating against the x-axis, I wouldn't have done anything to this. I would have just done x to the 8 squared minus 1 squared. And I think that was actually no. Okay. So anyways, now we have this. Now we're gonna FOIL this out. So we have 4 minus x to the 8th times 4 minus x to the 8th. We're going to use the FOIL method. So we have the first, which is 16, the outer, which is negative 4x to the 8th, the inner, which is also negative 4x to the 8th, and then the last, which is x to the 16th. And since we have a negative and a negative, that's going to make it a positive. So now we have this expanded out. Actually, we can simplify this even more. So we have 16 minus 8x to the 8th plus x to the 16th. And now we're going to combine this with this one, which is just a simple number. So that's going to be pretty easy. And I'm also going to rearrange these guys. To make it look nicer or more familiar. So we have pi integral from -1 to 1. I'm going to put this one at the front, followed by negative 8x to the 8th. And then it's going to be plus 16. But we have this 4 minus 1 is 3. 3 squared is 9. So 16 minus 9 is going to be plus 7 with respect to x. And now this is just going to be a basic power reverse power rule. So we have x to the 17th over 17 minus 8x to the 9 over 9 plus 7x evaluated from -1 to 1. This is not going to be a bad evaluation. Like, it's not going to be crazy, so I'll go ahead and do it. And again, I forgot to mention that we're multiplying that by pi. So we have 1 over 17 minus 1 to the 9th is 1. 1 times 8 is 8. So this is going to be negative 8 over 9. Negative 8 over 9 plus 7 minus the lower bound, which is -1 to the 17th. Since it's being raised to a odd value, it's gonna come out as negative. Since I'm hoping you guys understand the things that I'm pretty sure you guys understand the things that I'm doing. So anyways, we have -1 over 17, and then minus -1 again raised to an odd number. That's gonna remain as -1 times the 8 is gonna get you -8, but since you have a negative right here already, that's gonna make it a positive 8 over 9, and then that's gonna be -7, just like that. And now what I'm gonna do here is I'm gonna distribute this negative. So we have 1 over 17 minus 8 over 9 plus 7 plus 1 over 17 minus 8 over 9 plus 7. So we're gonna combine like terms. We have we'll combine like terms. So we have 2 over 17 minus 16 over 9 plus 14 times pi. I am not gonna go further on that, but that is gonna get you. Let me just make sure I have all my work right. Yeah, it's all right. if on a test, you would have to like, I mean, you could either plug it into a calculator and give like a long decimal, or if you want to keep it in a nice fraction, you'd have to set all these denominators. You'd have to find a common denominators for all these values. I'm not gonna go ahead and do that in this video. That would take too long. But if you did that, you would get 1888 all over 153. And do not forget about this guy right here. He goes on the top. That's gonna be units cubed. And that is the area that, I mean, not the area, but the volume that you get when you revolve these two functions around this line. Okay, so problem number 6 says to use cylindrical shells to find the volume of the solid formed by rotating the region bounded by y equals x to the power of 5 plus 3x and y equals 0 from x equals 0 to x equals 1 about the line at x equals 2. So our first curve, x to the 5 plus 3x, is going to be this curly one. And then we have y equals 0, which is this one, which is basically the same thing as the x-axis. We're looking at the region from, well, we're going to rotate the region from 0 to 1. So that's from this one and right here. And we're going to rotate it about the line at x equals 2, which is going to be somewhere like, I'd say like over here. I don't want to, I'm just going to go over that. But anyways, we're going to use cylindrical shells, so let's get right into it. The formula when we're doing cylindrical shells is a to b 2 pi x f of x dx. We know our bounds is from 0 to 1, so we could go ahead and write that. So from 0 to 1, 2 pi, and x, it would be x if we were rotating like about x equals 0 or y equals 0, but since we're rotating about x equals 2, we're gonna have to take that into account when we write this x. So instead of x, it's gonna be 2 minus x. So 2 minus x, and then just normal f of x, which is x to the power of 5 plus 3x dx. And here we're just gonna integrate like pretty much like how we would normally integrate. So let's go ahead and pull that 2 pi out. We have from 0 to 2, and we're gonna multiply these guys. I'm not gonna FOIL that out. I'm gonna use a square. So 2 minus x. So we have 2x to the power of 5, 6x, negative x to the power of 6, and negative 3x squared. We're going to rewrite that over here as 2x to the power of 5. Actually, let me write the biggest one first. So we have negative x to the power of 6 plus 2x to the power of 5 minus 3x squared plus 6x with respect to x. Let me just make sure I have this right. And I do. And now we're here. We're just going to integrate using a reverse power rule. So this is going to be 2 pi again. This is going to be negative x to the 7th all over 7 plus 2x to the 6th all over 6 minus 3x cubed all over 3 plus 6x squared over 2 evaluated from 0 to 1. Before I do anything, I'm going to go ahead and simplify this. So we have 2 pi negative x to the 7th all over 7 plus 2 divided by 6 is going to be 1/3. So 1/3. It's going to be 1/3. So these guys get canceled out. I mean, these guys cancel out with each other, so that leaves x cubed plus 6 divided by 2 is 3x squared, evaluated from 0 to 1. If you plug in a 0 here, this whole thing is just going to be 0, so we're just going to evaluate from 1. So we have, let me erase some of this so I can write it up here. So we have negative 1 over 7 plus 1 over 3 minus 1 plus 1 squared is 1. 1 times 3 is 3. 3. We could combine these terms. We have negative 1 over 7 plus 1 over 3. Negative 1 plus 3, that's plus 2. Multiply that by the 2 pi that we left outside. You will get on the test you should find the common denominator and do all the work for this. I'm not going to do all the work for the video, but I'm not going to do all the work for the video. So the final answer in fraction form would be 92 over 21. And don't forget about this pi. Pi. Of course, we're finding the volume. So this is units cubed. Moving on to the next problem, it says use cylindrical shells to find the volume of the solid formed by rotating the area bounded by the graph of x equals y to the 9 over 8 and x equals 0 from 0 to 1 about the line y equals 3. So our curve x equals y to the 9 over 8 is going to be this red one right here. And then x equals 0 is going to be this other red one right here, which is just a y-axis basically. And then our bounds are going to be from 0, which is right here, to 1. And we're going to be rotating around this y equals 3 line right here. I was able to draw it out like this, but I don't even know how to describe how this is going to look if I'm being completely honest. But anyways, let's just get straight into this problem. So cylindrical shells. So since now we're doing it with respect to y, it's gonna be the same formula, pretty much, just a little bit like it's just gonna look like that. Every x changes into a y. Now we plug in what we know. So we know a couple of things. So we have the integral from we know the bounds actually. It goes from 0 to 1. 0 to 1, 2 pi. And like in the last problem, since we're revolving around y equals 3, we're not just going to put y. We are going to put 3 minus y, like that. Again, I'm not 100% sure why, so I don't want to explain it, but that's just how you have to do it. And then we have f of y, which is going to be this function right here. So y to the 9 over 8 with respect to y. Now here we can integrate pretty basic integral. Let's just combine terms and then do the reverse power rule. So we have 2 pi 0 to 1, and we're gonna distribute this y to these guys. So we're gonna have 3y to the 9 over 8, and then negative y. This really has a 1 on it, so we're gonna add 1 to this 9 over 8, which is gonna make it 17 over 8, because 9 over 8 plus 1, which is going to be 8 over 8, that's 17 over 8 with respect to y. Now here we are just going to do a reverse power rule. So we have 2 pi, and then we have 3y, 9 over 8. 9 over 8, I mean not 9 over 8. 9 over 8 plus 1, we already did it over here. That's 17 over 8. So that's going to be 17 over 8. And then divide by the new exponent. But since we're dividing by a fraction, it's going to be the reciprocal. So we actually have times 8 over 17, like that. I'm hoping you guys understand what I did there. Now we do minus y 17 over 8. We're going to do the same thing. 17 over 8 plus 1, which we can rewrite as 8 over 8. 17 plus 8 is 25, and then 8. So your new exponent is 25 over 8, and you divide by the new exponent now. And like I said again, when we're dividing by a fraction, we're actually doing the reciprocal. We're actually multiplying by the reciprocal. I think I forgot to say that over here. So the reciprocal of this would be 8 over 25. So we have 8 over 25. Evaluated from 0 to 1. And now we can start evaluating. However, I am not going to do all the math, but I will write it out. So um we have a 0 here. If we plug in a 0 anywhere here, it's just going to end up making this whole thing equal to 0. So we're not even going to worry about that 0. So we have 2 pi, and we can multiply 8 times 3. That's 24 times 1 to this any 1 to any power except for 0 is just going to be 1. Wait, I think 1 to the 0 is actually 1 as well. Hold on, let me double check that. Okay, yeah, 1 to the 0 is actually 1. So, anyways, that doesn't matter. I don't even know why I brought that up, but 24 and then 1 to whatever that is just going to be 1. So we just have 24 over 17 minus 8 times 1 to whatever that is just going to be 1. So it's just 8 times 1 is 8 over 25. We have that. And that is the math that I am not going to do. But at the end of all that, you should get, if you find the common denominator for these guys, you will get 928 over 425. Don't forget about that pi. And common denominator, and then multiply that by 2. You'll get this number, and then you multiply by that pi, is what I mean. Units cubed, since we are doing volume. Alright, so the next problem says find the surface area of a revolution about the x-axis of y equals 3x plus 3 over the interval from 0 to 2. For this one, I didn't do a drawing because we don't really need a drawing to understand what's going on here. We're just finding the surface area of this guy when we revolve him around the x-axis. So that's pretty simple to understand, I hope. Anyways, we're surface area. We're doing surface area. So let's write down the formula for surface area, which is the integral from a to b 2 pi f of x multiplied by the square root of 1 plus f prime of x squared with respect to x. Okay, we have everything that we need. First of all, yeah, we have everything we need except this f. We don't know this f prime, so let's go ahead and figure that out right now. F prime of x is going to be the derivative of this, which is just 3. So now let's go ahead and rewrite this whole thing with everything that we know. So we have the integral from 0 to 2 pi f of x, which is 3x plus 3, multiplied by 1 plus f prime of x, which is 3, squared dx. A lot of stuff is going to get pulled out. So we have, first of all, we're going to pull out the 2 and the pi. 0 to 2, 3x plus 3. And we're going to simplify in here. 1 plus 3 squared. 3 squared is 9. Plus 1 is 10. So we just have the square root of 10, which is a constant. So we'll go ahead and pull that out, and we'll pull them right there. Dx. Now here we're just going to do a reverse power rule. So we have 2 square root of 10 multiplied by pi. And we are reverse power rule right here. 3x squared over 2 plus 3x. Evaluating from 0 to 2. If we plug in a 0 here, it's just going to make the whole thing, not the whole thing 0, but if we plug in a 0 right here, that's going to be 0. Plug in a 0 right there, that's going to be 0. So 0 plus 0 is 0, so we're not even going to plug that in. So then we have 2 square root of 10 multiplied by pi. 2 squared over 2 plus 3 times 2. That is going to get you 2 square root of 10 multiplied by pi. 2 squared is 4. 4 times 3 is 12. 12 divided by 2 is 6. Plus 6 is 12. 12, this 12 we could multiply by this 2 right here. So we have 24 square root of 10 pi. And since we are doing surface area, this is going to be units cubed. I mean units squared. Units squared. Alright. Alright, so the next problem says let C be the curve y equals 7 square root of x for 1.1 to 3.7. Find the surface area over the axis of R. So I already have the surface area formula set up here, so we're just gonna find everything that we need. We know f of x, we know our bounds, but we don't know f prime of x. So let's go ahead and find that. So f of x is equal to 7 square root of x. F prime of x, we can ignore that 7 for right now, and we'll just deal with x. You can rewrite this as x to the 1/2, and then we'll just do power rule. So that's going to be 1/2 x to the negative 1/2, and negative 1/2 we can rewrite that as 1 over square root of x, and then we have this 1/2, so it's going to be 1 again, and then 2 at the bottom. And then we have to square that. Oh, also we have this 7, so plug that 7 back in. So really we have 7 to root x, and now we square that. We get 49 over 4x, because the square root, we're squaring the square root, so that square root goes away. Anyways, let me go back over here. I have from 1.1 to 3.7. I'm going to go ahead and pull out that 2 pi. And then I have f of x, which is 7 square root of x multiplied by the square root of 1 plus 49 4x dx. Now here I have a constant that I can pull out, which is the 7. So I'm going to go ahead and pull that out. So I have 14 pi integrating from 1.1 to 3.7. And by the rules of algebra, since I have a square root right here, since both of these things inside the square root, well, since I have 2 square roots, I can combine them. So I'll make it all into one big square root. So I'll have x multiplied by 1 plus 49 over x over 4x dx. And now I'm gonna distribute this x, so I'll have 14 pi from 1.1 to 3, looks like a b, to 3.7 square root of Distribute that, so that's x plus 49x all over 4x. So these x's will cancel out. So we have 49 over 4 dx, and now we could use a simple u substitution, making u equal to x plus 49 over 4. So then du is just going to be equal to 1 dx, or just dx. So now we can do this. So we have 14 pi from 1.1 to 3.7 square root of u, or I'm actually going to go ahead and rewrite that already, u to the 1/2 du. And now we just do a reverse power rule here. We are going to end up with 14 pi u to the 3/2. And I'm also going to rewrite these as fractions. I mean, not fractions, but decimals, because I don't like working with fractions. So 1/2 plus 1, 0.5 plus 1 is 1.5. 1.5. Evaluating from 1.1 to 3.7. And before I do anything else, I'm going to put back this u, which was x plus 49 over 4. I can erase this. So we have 14 pi evaluating x plus 49 over 4, x plus 49 over 4 all over 1.5. I'm going to go ahead and pull out this other 1.5. So it'll be 14 divided by 1.5. And then on this, it'll be minus. Okay, hold on. Evaluating from 1.1 to 3.7. And then now I can start plugging in my values. I'm going to plug them in, but I'm not going to show all the math. So we have 14 pi all over 1.5. And then we have 3.7 plus 49 over 4 to the 1.5 minus 1.1 plus 49 over 4 to the 1.5. And finally, you will get an answer of 139.276. There's other decimals, but I'm going to just cut it off right there. Times pi units. Since we're doing surface area, that's going to be units squared. All right, so we're down to the last two problems. We are almost done. Problem number 10 says how much work is done lifting a 25-pound object from the ground to the top of a 30-foot building if the cable used weighs 0.5 pounds per feet. And the problem tells us, actually it doesn't tell us anything, but like, okay, anyways, so first I'm going to break up this system or this problem into two parts. So I'm gonna do the work done just lifting the object, and then the work done lifting the rope. So for the object weighs, so work is given by this formula. So work equals the force times the distance. If the force is constant, if the force is not constant, then work is given by the integral of force. Hold on, I need to double check that. It's given by f of x, which is the force function with respect to x. So now we have, okay, so for the object, the force is going to be constant because the object is just being pulled down by gravity. Gravity is a constant force, so that's just going to be the work equals the force. which the force is already given to us because we are told that it weighs 25 pounds. So that's just going to be 25 times, I'm going to keep the units out for right now, but 25 times the distance that it goes up, it has to go up 30 feet. So that's 25 times 30, which is going to give you, I believe it is 750 foot pounds of work. That's just for the object. Now for the rope, since the rope is changing, like it's not changing its weight, but as you pull more rope, the rope gets lighter. If you understand it, right? As you pull more rope, the rope remaining is gonna get lighter. So for this one, we're gonna use integration. So we have the work equals, and it's gonna be pulled up 30 feet as well. So we're going from 0 to 30. F of x, for f of x, it's gonna be um the weight. So it's 0.5 multiplied by the distance that it goes. So it's gonna be 30 minus x dx. And now I can combine like terms, or not combine like terms, but distribute. So we have that the work is equal to the integral from 0 to 30 from 15 minus, we could do x over 2 dx. Actually, I don't like fractions, so I'll do 0.5 x dx. And then now we just use reverse power rule. So we have that the work is equal to 15x minus 0.5x squared over 2 evaluated from 0 to 30. If we plug in a 0 here, we get 0. If we plug in a 0 here, we get 0. So 0 minus 0 is going to be 0. So we'll just plug in the 30. So we have 15 times 30 minus 0.5 times 30 squared all over 2. That is going to equal 225 foot pounds. Normally in physics we say Newton meters, but since we're working with feet and pound, we have to say foot pounds here. So it's asking how much work for the object, and since you have to use the rope for the object, of course, we're gonna add these works up. So we have 750 plus 225. That is gonna get you a grand total of 975 foot pounds of work. Finally, we have arrived at the last problem, and it says a circular swimming pool has a diameter of 10 meters. The sides are 4 meters high, and the depth of the water is 4 meters. How much work in joules is required to pump all the water over the side? Take G to be equal to 9.8 meters per second squared, and the density of the water to be 1,000 kilograms over meters cubed. Okay, so first we're going to write down the formula for work when we're doing when we have like a pumping situation. So that is going to be the integral from A to B rho times G. And then we have B minus Y, and then W of Y dy. Okay, so now we're gonna plug in everything that we know. All right. So rho is just the water density, and then g is of course the acceleration from gravity, which those are both constants. So we can actually already go ahead and pull that out. So we have 9.8 times 1000, which is going to give you 9,800. And we know our bounds actually. Since we want all the water to go out, and the water is 4 meters deep, or the water is 4 meters, and the walls are also 4 meters. So that's going to be from 0 to 4. B minus y, since our base is at 0, this b minus y is just going to be 4 minus y. And then we have w of y, which is going to be the area of the cross section of the pool, which we are told that it's a circular swimming pool. So the area of a circle is pi r squared. Pi r, we know that the diameter is 10, so then the radius is half of that, which is 5, and then we square that, so that's 25. So look, we have more constants, right? So we can pull those guys out as well. So we have 20, not 2 pi, but 25 pi multiplied by 9,800, integrating from 0 to 4. Wow. 0 to 4. And we're doing 4 minus y dy. And here we're just gonna do reverse power rule. So we have, I'm not gonna rewrite this for right now. So right here we're gonna have 4y minus y squared over 2, evaluating from 0 to 4. If we plug in a 0 here, we'll get zeros. So we'll just plug in the 4. So that's going to be 4 times 4 is 16, minus 4 squared is 16, divided by 2 is 8. So that equals 8. So our big number is going to be 25 pi 8, 9,800 joules. If you want to combine that or plug that into a calculator, you'll get I think I have the wrong number here. You're gonna get, wow, that is a big number, so I'm not even gonna write it. I'm just gonna write it in scientific notation. So that's gonna be 6.16 times 10 to the 6 joules. Thank you guys for watching my video. I know this video is late because we have the test. By the time this video is uploaded, my class has the test the next day. But hopefully this helped you understand like something last minute, hopefully. And yeah, thank you guys for watching my video. Please leave a comment, and for future tests I will try my best to get a video on them earlier, better than a day before. And I also will try to go more into depth about like the techniques that I use. Although since you're watching my videos, I'm assuming you're in calculus too, and I'm assuming you know what I'm doing, right? I think so. But if you don't, please leave a comment, and I will be more than happy to go more into depth or go slower with my work or explain what I do more. And I also will try to, I'm good at doing the problems and like following the techniques, but I'm not that well at like understanding why I do what I do. So I will try to be better at that, so I don't leave you guys Like I don't say like I'm gonna do this. I don't want to say it. No, no, no. I don't even make sense right now. But I don't want to say like I'm gonna do something, but then I'm not gonna explain why I do it because I don't want to make a mistake on the things that I say. So I'm gonna try to be better at that. But thank you guys for watching my video. Please leave a comment, something. Leave a bad comment, a good comment. Please leave some sort of feedback so I can improve. I will not be offended, but I will not be offended, but nothing. I will not be offended. So please leave some feedback. I don't care what it is. Just I want to make these videos better. So please leave feedback. Any feedback, good, bad. I don't care. Thank you guys for watching my video, and hopefully you guys pass the test with 100%.